Okay, good evening everyone. So as I said before, we'll be going through MC and the structured questions for the test 5. I'm going to be explaining for MC step by step, so hopefully you'll be jotting down notes at the same time. Why is it correct or why is it wrong? So let's start off with the first question. Now we have 3 setups. The main difference is the rods they're using, the metal rods. So we have zinc, iron, copper, and zinc, copper. So the first question is, which of the following are the correct order of brightness? So first thing you have to know, what is the brightness depends on? So if they have the same rod, will there be any electrons moving through the light bulb? So if you have that concept, this question should be piece of cake. But from judging by the test I marked, 50% of you got this correct only. The main reason was you did not know what does the brightness mean. So let's have a look. Now, first we have to check their electrochemical series. So the highest one over here is zinc, followed by iron, and then copper. So if I have a chemical cell set up between zinc and iron, compared with zinc and copper, which one will lose electrons more readily? Okay, yes, the answer will be 3. So the electrons given out between zinc and copper, since the difference is larger, so electrons given out will be more. So the brightest will be number 3. And then followed by iron and copper, and then last will be zinc. So the answer will be D. All right, question 2, a very simple setup. We have lead electrode and silver electrode with a salt bridge, lead 2 nitrate and silver nitrate. So which of the following are correct? Lead is an anode. So as we know that since lead is at a higher position in electrochemical series than silver, so lead will lose electron. So the chemical equation for this side will be Pb2 positive, Pb solid will become Pb2 positive and 2 electrons. So electrons will be lost over here, and then silver will gain electrons. So 1 is correct. This is anode, lose of electrons. Gain of electrons will be cathode. Next, electrons flow from lead to silver in the external circuit. Yes, correct? Salt bridge can be prepared by sodium sulfate. Now here you have to be extra careful. The reason is we have a sulfate here. Sulfate ions tend to react with cations. Sometimes they will form precipitate. So we have to check whether any precipitations will be formed. So sulfate will react with silver. Does it have precipitate? Yes. So silver sulfate will give white precipitate, as well as PbSO4, the classic, also gives out white precipitate. So this chemical cell will just be functioning for only 1 minute. So therefore 3 will be wrong. So instead of using sodium sulfate, the best option will be using sodium nitrate. Okay, in this case, nitrates tend to not have any precipitation with any cations. So in this case, the answer will be A. Okay, moving on to the third question. Which of the following reactions is not a redox? So redox means one increases and the other decreases in oxidation number. That's the fastest way to check. So let's have a look at the first one. Nitrogen. So the oxidation state of nitrogen here is, since it's gas, so it must be 0. Hydrogen, 0. What about nitrogen over here? So nitrogen will be, let's say, X equals plus positive 3 equals to 0, because 1 times 3. So X is negative 3. So in this case, nitrogen is negative 3 and X is positive 1. So you will notice nitrogen decreases in oxidation state while hydrogen increases. So therefore, this is a redox reaction. But now we're asking for not redox reaction. So let's move on to the next one. So sulfur, this one is become positive 4. Why? Because you can just calculate on your own. And this one will also remain positive 4. So you will notice that sulfur has no change in oxidation number. Therefore, the answer will be B. You can also do the checking for the C and D on your own. Moving on to question 4. Which of the following is incorrect for the lithium ion cell? Now, there's nothing for me to explain because this one is memorization, but the obvious is that lithium ions are actually really, really small. So out of these 4 options, the only one that makes sense is that it cannot be used in car batteries because car batteries are generally really, really big. So therefore, the option will be B. All right, the 5th question. Which of the following is the best conductor in molten state? So again, molten state, only ionic compounds. So wax is not ionic, sulfur is not, iodine is not. So the only option is A. All right, moving on to question 6. Oxidation number of manganese in manganese oxide. So we let manganese be X, so 2X plus negative 2 times 3 equals to 0. So 2X equals to 6, so X equals to positive 3. All right, moving on to number 7. Balancing equation, I'm not really going to explain detailedly. So all you have to do is look at which variable is changing. So over here, I noticed that we have sulfur. Sulfur is fixed, so that's why I don't have to worry about it. And now the next thing I have to worry about is the number of hydrogen. Now we have 2 hydrogens and 1 hydrogen that is variable. We don't know. So 2 here and then 4 over here. So that means 1. So 4 is balanced. Now what about for chlorine? So chlorine, we have 3 here and 3 here. And then moving on to iron. So what is not balanced? The balance is actually the oxygen. We have oxygen over here, 3, and then here only 4. So after doing options, so the only option will be B. Okay, 2 to 2. All right, number 8. When chlorine is bubbled into hot concentrated potassium hydroxide, the following reaction occurs. Now, you might not have seen this reaction, but that doesn't mean you don't know how to do it. So just look at the question and see what they're trying to ask. So potassium hydroxide solution acts as a reducing agent. Now, realize many of you don't know what's reducing agents. Now, reducing agents are something that undergo oxidation. So that's the first thing you have to establish. After you realize that, okay, reducing agents are something that undergo oxidation. What is oxidation? Lose of electrons. So, is potassium hydroxide losing electrons? Can you find out? No, because this is not an ionic equation. So what do? Instead of finding lose of electrons, what's the other method? The other method will be increasing in oxidation number. So there are 2 ways to tell whether it is a reducing agent or not. One, by finding out which is oxidation number, and the other one will be lose of electrons. So let's have a look. Potassium here is positive 1. And then over here it's also positive 1. If you ask me, sir, how did you calculate? Please do it on your own. Okay, it's just making X as a subject and then solve it. So you will realize the X is not moving. The oxygen also, you can try it, you will realize it's not changing. So therefore 1 is definitely wrong. So I cut out the option of A and C. So the only option left is B and D. Now chlorine acts as a oxidizing agent. So over here, chlorine is 0. And over here, so this one I'll put it over here. Potassium is positive 1 plus X plus negative 2 times 3 equals to 0. So negative 6, X and positive 1 equals to 0. So 6 minus 1, so X equals to positive 5. So in this case, chlorine here is positive 5. What about here? Pretty simple. K is positive 1, Cl will be negative 1. So we notice that chlorine for this one, increase in oxidation state. That means increase in oxidation state undergoes oxidation. If it undergoes oxidation, that means this is a Ra. So 3 must be correct. And we also realize that oxidation number decreases. If oxidation number decreases, that means undergoes reduction. If it goes reduction, that means it's oxidizing agent. So the answer is 2 and 3 will be D. Moving on to question number 9, Daniel cell. Again, nothing for me to discuss. The most crucial mistake where most of you made was many of you chose to prevent the mixing of electrolytes. That is correct. You don't want to mix the electrolytes because the charges will be going out of balance. To provide ions to balance the charges in the electrolytes. There is no salt bridge here. So who will be providing ion? So therefore 2 must be wrong. So if I cancel out 2, there's only one option, which is B. Okay, next, very simple orange cell. Lead, zinc. So zinc will be losing electrons, so electrons will be moving this way. Orange contains electrolytes. Yes, electrons flow from lead to Z, which is wrong. And zinc is a negative electrode. Yes, anode, so negative, so the only option will be B. Okay, moving on to number 11. Number 11, potassium sulfite reacting with acidified potassium permanganate. So that means sulfite will turn into sulfate. And permanganate, MnO4 negative, will turn into Mn2 positive. As you know, sulfite are colorless, so we don't have to worry. Potassium permanganate, so from purple to colorless. So which means the only option will be C. Number 12, concentrated nitric acid. Strong OA, definitely, because it can oxidize basically anything. It reacts with limestone to give nitrogen dioxide. Now that is not true. The way how ConNO3 works is that when it reacts with limestone, so if you know limestone is calcium carbonate, it just behaves like a normal acid, which gives out salt, which is CaNO3, when water, carbon dioxide, but this case, it will, since it's concentrated, it also gives out nitrogen dioxide. Okay? So, oh wait, sorry. It doesn't give out nitrogen dioxide. It only gives out carbon dioxide. So therefore, 2 cannot be the answer. And reacts with zinc to give out hydrogen. Zn plus H positive gives out Zn 2 positive plus H2. Okay, so the answer for number 2 will be only A. Okay, it will not give out nitrogen dioxide. So the only, actually this one gives out nitrogen dioxide as well, because it's concentrated. Okay, moving on to the question 13. Now for question 13, which one is oxidizing agent? So that means undergoes reduction. If it undergoes reduction, that means decrease in oxidation number. Now if you cannot have this flow chart in your mind, don't even bother doing this question, okay? So whenever we're doing OA and RA, we have to do step by step, go back to the basics. So let's have a look at the first one. Over here, let's look at Na. Na is positive 1, and over here is also positive 1. And so therefore, the oxidation state has not changed. What about for this one? Now the sulfate remains the same, 2 negative, 2 negative. But look at the copper. The copper is positive 2 here, and it becomes 0. So decrease in oxidation number, that means it's reduction. That means it's a OA. So the answer will be B. Okay. Now moving on to 14th. Again, this one is just memorizing. So the only option will be D. Okay, these are all correct. 15, concentrated nitric acid. Many of you were picking A and D. That doesn't make sense. Now, iron 3, if you oxidize iron 3, you have to add electrons here. Oxidizing means losing electrons. So how will it lose electron from iron 3 to iron 2? So it cannot be A. And most of you also picked calcium carbonate. Now, how will I know whether there will be any nitrogen dioxide form? And will there be? Now, if you remember this question, number 12, there won't be any nitrogen dioxide form if I react with con-nitric acid. So therefore, we won't know if it has an oxidizing property. So the only option will be sulfur, because when it reacts with sulfur, it gives out SO2 and NO2. So the option will be C. And why is it not B? Because when it reacts with sugar, we can only see that sugar will turn black. There's no way to see that whether it is because of its oxidizing property. All right, number 16. When the circuit is closed, so first distinguish what is the electrolyte. Now, electrolyte is dilute sulfuric acid, and they're in the same beaker. So dilute sulfuric acid has H positive and SO4 2 negative. So obviously electrons will be flowing from zinc. So zinc becomes zinc ion plus 2 electrons, and then we'll be receiving it from silver. Now since silver is metal, who will be receiving the ions? The electrons. Will it be silver? Now silver metal will not be receiving electrons to form silver ion. That is wrong. Okay? So who will be receiving electrons? The answer is very simple. It will be hydrogen. Hydrogen, when it receives electron, it will form hydrogen gas. So you just balance the equation. So this is the part where many students often make careless judgment, is that, oh, they see silver, so definitely will be gaining electron. But if you remember, it's the solution that gains electron. We don't have any solution with silver. So therefore, the only option for the electrons to be gained is by the hydrogen ion. So electrons flow from zinc to silver, correct? Hydrogen ions are reduced. Is that the case? Yes. Gaining of electrons, that means they are reduced. Both metal electrodes gradually dissolve. Now, zinc is losing electrons, so that means only zinc will be dissolving. What about silver? Now, silver is not being changed at all because it is not being losing electrons, so it cannot be both. So only zinc. So the answer will be only A. All right, last question for MC. This is the complicated setup, but if you look at deeply, you will notice that it's actually the same concept, but it's just using fancy elements. Now, which of the following statements is correct? Electrons flow from copper to chromium. Now, even if you realize that you have not learned transition metals in the electrochemical series, you should definitely know that chromium must be higher than copper. Okay? Even if you don't have this fact, but using your concept, chromium must be higher. Any transition metal will be higher than copper. Copper is nearly the end. So, chromium will lose electron and will be gained by copper. So over here, the equation will be losing electron. How many electrons? 3 to form chromium metal. Whereas this one will be, sorry, my bad. It should be the other way around. So chromium loses electron to form chromium and then 3 ions. And then copper will gain electrons to form copper solid. So this will be happening on anode, cathode, and this will be happening on anode. Electrons flow from copper. That is not true because it should be flowing from chromium to copper. Oxidation occurs at chromium electrode. Losing of electron, that means oxidation. So this is correct. But let's check what about C. The concentration of chromium 3 ions in the chromium 3 sulfate decreases. Now you will realize that for this equation over here, there are already chromium ions here, but I am giving out more chromium ions because I'm losing electrons. So the concentration of chromium ion should be increasing, not decreasing. The blue color of the copper 2 sulfate solution becomes more intense. So let's look at this one. Equation. Copper 2 ion, which is blue, are becoming solid. So that means the blue should be becoming less intense because copper ions are forming copper metal. So metal has no color, only the solid will be formed on the electrode. So it should be less intense. So I hope throughout these 17 MC questions you have a better understanding of chemical cells. And I really, really hope that you have made all the notes that I've been making, the misconceptions you have for this chapter. You have to make sure you write this down because when you're revising for MC, the best way to revise MC is not look at the correct questions you have answered, but the wrong ones and why are the options wrong. Then you will truly understand whether you know this topic or not. So I'll stop here for MC and then we'll move on to the next video for structured questions.